Hello and welcome to this video that introduces the Mathematics Initial Teacher Education at the University of Sussex. My name is James Bashford and I'm an Associate Fellow here in the School of Education and Social Work at the University, and I'm the Secondary Maths ITE course lead. Worth noting, I'm also still a teacher of maths, so I teach maths 2 days a week, the equivalent of 2 days a week, and I also have another role as the Sussex Maths Hub Post-16 lead. You might have heard of Sussex Maths Hub, you may not, worth looking it up online. So, what are we covering in this video? Well, first of all, we're going to talk about what it's like to be a secondary maths teacher and in turn a secondary maths trainee teacher. We're going to think about the kind of subject knowledge you need for teaching, so subject knowledge for teaching, and how to develop that. We're going to think about what to expect in the maths curriculum sessions during both induction, so 3 weeks in September at the start, and also on Fridays during the course. And then finally, we'll think about how you can best prepare for your interview and for the course if you're successful. So, starting off with what it's like to be a secondary maths teacher. Now, clearly, because I'm still teaching, I think it's a fantastic career. It is a really, really rewarding job, but as I'm sure you're aware, it is a full-on job as well. So, secondary maths teachers mostly would teach both Key Stage 3 maths, so that's 11 to 14 year olds, year 7 to 9 in most schools, and also Key Stage 4 maths, so years 10 and 11, 14 to 16 year olds, at the end of which they study or they take their GCSE. Or most students would take their GCSE. Many maths teachers also teach A-level maths, so A-level maths to 16 to 18 year olds, and some of you may be interested in doing that. This qualification, this course does prepare you to teach A-level maths, and the qualification allows you to teach A-level maths, but there are plenty of teachers that don't teach A-level maths, so don't feel like you're going to have to. Worth noting though that there's many other courses that secondary maths teachers often teach. So many of you will have heard of the GCSE statistics course, which some students study alongside their GCSE maths. Probably fewer of you know about the Level 2 Further Maths course. So Level 2 is GCSE equivalent, and there is a GCSE or Level 2 Further Maths course, which kind of links or bridges the gap between higher GCSE maths and A-level maths. So some higher attaining students in schools in year 10, perhaps 11, would study Level 2 Further Maths. And there's also another Level 3 course, so Level 3 is A-level equivalent, and this course is known as Core Maths, and it is very much aimed at applying maths, and so it's really using maths, using various parts of maths. So there's a lot of work on data, but also geometry, and it's about using those ideas in real life contexts. And then finally, many of you will have heard of the A-level Further Maths course, which is an extra A-level that can be taken on top of A-level Maths that just looks at more difficult concepts in a bit more depth. So all of those are available, or many of them are available in schools, but teachers would usually be approached to see whether they would be happy to teach those courses. Thinking about subject content, and so what subject content will you need to be teaching? Well, the national curriculum, both Key Stage 3, Key Stage 4, has these different parts, different areas of study. So obviously we need to teach number, so working with fractions, using standard form, estimating, carrying out calculations, and then algebra. So algebraic manipulation and solving equations. Ratio, proportion and rates of change is a huge part of the current GCSE and hence Key Stage 3 and Key Stage 4 curricula. And then there is geometry and measures, so working with angles, shapes, looking at area and volume. And then there's probability and statistics, some of which, or both of which, some people really love, and others really are not so keen. Unfortunately, it can be something that's can be taught in a very boring way, but in my view, it can actually be taught in a really, really interesting way as well, where we're really trying to get our students to have a deep understanding of probability and statistics. Overarching themes in the national curriculum are developing fluency, so we want our students to know the important facts, but we also want them to be able to work fluently and show their working out, carry out calculations fluently. Mathematical reasoning is a very big part of the current GCSE, and students need to be able to carry out calculations, but they also need to be able to reason for their choice of method and for the approach that they've taken. And then problem solving is a much bigger part in the current GCSE than in previous GCSEs. Problem solving is really all about students being able to carry out calculations and know how to approach questions that are not very similar to questions they've seen before. And then also we've also got, of course, got to think about the use of ICT. So included in that is how we best make use of calculators. So at GCSE there is a non-calculator paper, but there's 2 papers where they do use calculators. At A-level all of the papers use calculators, and the current calculators used have a much bigger part to play. They can carry out a lot more calculations. But also in the use of ICT, we can think about how we use dynamic software to help students learn, to help us teach and students learn mathematics. So on to thinking about subject knowledge for teaching. One important idea is that you do not need to have a maths degree to train to teach maths. When we think about subject knowledge for teaching, obviously content knowledge is important. So you definitely need to know the maths that you are going to be teaching. However, it's just as important to know about pedagogical knowledge, to have pedagogical knowledge, which is all about knowing how best to teach the content. And so really, the subject knowledge for teaching that you need is the crossover of those 2 aspects, which is known as the pedagogical content knowledge, PCK. And we think of that as what subject knowledge for teaching is all about. So if you don't have a maths degree, you will be required to complete a subject knowledge enhancement course, and that is just to make sure that your content knowledge is where it needs to be before you start your initial teacher education. Also though, on the subject knowledge enhancement course, we tried to think about pedagogical knowledge as well. So during the course we talk about how we could teach different aspects of maths. The SKE course, Subject Knowledge Enhancement course, we run here at the university, and there are 3 different courses. There's a 28-week course, a 20-week course and a 12-week course. And during your application and interview, we will discuss which course, if any, is going to be most appropriate for you so that you're best prepared for your initial teacher education year. Worth noting that it is a funded course, and so it's funded by the Department of Education, and that means that it is not only free to participants, but also that there is a bursary available. It's quite a small bursary, but there is a bursary available during the course. On average, it is a 25-hour week course, although here at Sussex University we tend to work on a kind of 30-hour a week course, but then have holiday weeks. So thinking about the curriculum studies sessions, an important idea really is at first is exploring the basic lesson structure, and I'm sure most of you will remember from your GCSE lessons or your maths lessons at school that the teacher would often explain ideas and then you would do some practice on those ideas. A fairly basic approach that is of course still used regularly in classrooms today. What you might not have noticed, or you might not remember so well, is that there was constant assessment going on. So as the teachers were explaining things to you, they were assessing your understanding of their explanation, perhaps through questioning or use of mini whiteboards. And then with the practice, or following the practice, perhaps during the practice, there also needs to be assessment going on to check that students are understanding. Obviously, in any maths topic, there is going to be prior knowledge that the students need to access that content. So what we need to be able to do is assess that prior knowledge before we take on or we offer new ideas to our students. Many of you will have had starter activities or do now activities at the start of your lessons, and perhaps some sort of plenary activity to assess students at the end. And that plenary activity can often be used to assess students so that we have a better idea of what their prior knowledge is going to be in the next lesson. So much of our induction time is spent exploring this basic lesson structure and thinking about how we best do each of those different components. We also get our trainees to practice all of those different elements using our CAFE approach. And the CAFE approach simply stands for construct, activate, feedback and evaluate. So for instance, our trainees might construct worked pair examples, a set of worked pair examples. They then might teach it to their fellow trainees or to a small group of them, who would then give them feedback on their explanation, allowing the trainee to evaluate their activation. All right. So here are some photos of some of our trainees who are doing an explanation to 2 or 3 other trainees. We try to model best practice. So we have a spiral curriculum. That means that we will do some work on explanation, but then later in the course we'll come back to that idea to advance it a bit further. We have a coherent curriculum, which means we start with the most basic ideas and then gradually we take on more complex ideas throughout the year. We make regular use of exit tickets to assess how our trainees have understood each session. We also make regular use of recall, so giving students questions on ideas that we've previously discussed. And of course, our whole curriculum is research informed. We recognise that some or many mathematicians perhaps don't have as much experience of academic reading and writing, and so during our curriculum studies we make sure we give plenty of input on these ideas to make sure that everyone is confident. We also look at many other ideas, so the concrete representational abstract, or sometimes known as concrete pictorial abstract, is an idea that's used in many schools these days, and it's all about how we can best use representations to help our students understand the abstract nature of mathematics. We also use, as I said earlier, some dynamic software, graphing software, geometry software to help students explore the maths and get a better depth of understanding of the maths. We'll also look at mathematical investigation. So it's really important that our students are prepared to explore mathematics for themselves and to investigate problems themselves. And finally, we also look at how best to make use of group work. Group work, working collaboratively, is a really important idea in teaching mathematics, so we do run sessions looking at that as well. Obviously, there are plenty of other things we discuss in our sessions, but that gives you an idea of some of them. So, how can you best prepare for your interview and, if successful, the course itself? Well, the first thing is, if you don't have a maths degree, you need to apply early. And that is so that we can make sure that you can access the length of subject knowledge enhancement course that you need ready for the course. You should definitely have a go at some higher GCSE maths papers. Some of you might have taken the GCSE from 2017 or onwards, but if not, then you will have done an older style GCSE paper, and they have changed. So have a look online and try some past papers. Definitely worth reading the national curriculum for each of Key Stage 3 and Key Stage 4 maths. Again, that's easy to find through an internet search. There's plenty of really good books out there on how to teach maths, so definitely worth having a look. And if you Google search, then I'm sure the most popular ones or the most read ones will come up, and you can have a read of some of those. But perhaps most importantly, you need to get into schools. You will all remember your own maths lessons from school, which I'm sure varied throughout your education. However, you need to get into schools these days and see how maths is being taught these days in schools, and that is really important. There is help for trainees or prospective trainees to do that through the Get Into Teaching website. If you do have any questions, then please do feel free to contact me. So there's my email address there, j.r.bashford@sussex.ac.uk. And I really look forward to receiving your application or any questions you might have. Thank you very much.